Okay, so welcome back. So now what we're going to be doing is talking about values of trigonometric functions. Okay, so the first thing we're going to do is we're going to talk about a special triangle called the 30, 60, 90 triangle. Okay, so if we look at, again, a point, right, on the XY coordinate plane, right, I'm going to do two of these. Okay. And so if we draw two triangles, 2 points, okay, and I draw a triangle like this, okay, so now let's make this angle here 60 degrees and this angle here 30 degrees. Now, one of the special things we know about these triangles, the 30, 60, 90 triangle, is that the side opposite the smallest angle, which is 30 degrees, is half of the hypotenuse. It's one of the things we know. So if we look at the hypotenuse, the relationship here, we use that to fill this in. In general, right? So in general, one of the things we know, if this is 60, then this has to be 30 degrees, right? Because again, the angles of a right triangle or any triangle has to add up to 180 degrees, right? So if this is 90 and this is 60, that means this has to be 30, right? So then this would have to be 60 over here. Okay, so now this is our theta, right? So this is theta here. Okay, now, again, let's use the fact that the opposite angle, so let's look at the 30 degree angle. We know that this side opposite the 30 degrees is half, right? Half of the hypotenuse. So if this is x, then our hypotenuse would have to be 2x. Okay? So if we just take a triangle, a 30, 60, 90 triangle, where this is 30 degrees and this is 60 degrees, then we would know if this is x, whatever that side is, we don't know, but what if this is x, then this would have to be 2x. And then if we use the Pythagorean Theorem to solve for this, right, to solve for this missing side, well, what would we get? Well, what you would get is, well, let's figure it out. So you get 2x squared plus, oops, not plus, let me do it this way. So let's say this is A, we'll call it A, okay? So we know A squared plus x squared equals 2x quantity squared, right? We're just using the Pythagorean Theorem. So then a squared has to equal what? This is going to be 4x squared, right? Then minus x squared, right? And so if I then simplify this, right, this means a squared equals what? 3x squared. And then if I take the square root of both sides, a equals the square root of 3x squared. And then of course, this is going to equal what? X times the square root of 3. So now, what if I say, hey, this is a unit circle. So what if I say x is 1? Okay? If x is 1, then all of these units become what? Just square root of 3, 1, and 2. And so we get this relationship for a 30, 60, 90 triangle. So that means that if I have a 60-degree angle for theta, I can label our 3 sides. If I have a 30-degree angle, I can still label all 3 sides. It just depends on what x is, right? If I know what x is, then I get all 3 sides. If x is 1, then I've got a unit circle, right? Which means then it just becomes 1, 2, and the square root of 3. So again, the hypotenuse is always the largest side, the longest side, so it's 2. The side opposite of the shortest angle is always the shortest side, so this is 1. And then you just have to remember that the side opposite the 60-degree angle is square root of 3. Okay, so it's 1, square root of 3, 2. Okay? So that is this 30, 60, 90 triangle. So that means when I'm doing my sine, cosine, then sine of 30 degrees, okay, cosine of 30 degrees, and tangent of 30 degrees, right? Now I'm finding the value of actual angles, right? So sine, cosine, tangent, and then we've got cosecant, 30 degrees, secant, 30 degrees, and cotangent, 30 degrees. And then of course I've got sine 60 degrees, cosine 60 degrees, tangent 60 degrees, and then I've got cosecant 60 degrees, secant 60 degrees, and cotangent. $60. Okay, now if I know this 30, 60, 90 triangle, then I can get these pretty easily, right? So in this case, sine of 30 degrees is going to be what? Opposite over hypotenuse. So this is always going to be a half. Cosine of 30 degrees is the square root of 3 over 2. Tangent of 30 degrees is 1 over the square root of 3. Cosecant of 30 degrees, which is the reciprocal of sine, which is going to be 2. The secant, which is reciprocal of cosine, is going to be 2 over the square root of 3. And then cotangent is the reciprocal of tangent, which is just going to be the square root of 3. Okay? Those are going to be always the fact if you're dealing with cotangent of 30. These ratios will always be the same. Okay? Okay, now, sine of 60 degrees, or the trigonometric functions evaluated at 60 degrees are very similar. Okay? Except now your reference angle is 60 degrees. So the sine of 60 degrees is what? Opposite over hypotenuse. So from the 60 degrees, it's opposite over hypotenuse. So this is going to be square root of 3 over 2. The cosine of 60 degrees, right? So again here is going to be adjacent over hypotenuse, which is 1/2. Okay. Tangent of 60 degrees is going to be opposite over adjacent, which is going to be square root of 3. Cosecant of 60 degrees, well, that's going to be the reciprocal of sine. So it's going to be 2, right? So it's going to be the reciprocal of sine, which is going to be, sine is this over this, so it's going to be 2 over the square root of 3. Okay? And then secant is the reciprocal of cosine, which is going to be 2. And the cotangent is the reciprocal of tangent, so that's going to be 1 over the square root of 3. Okay, that's it. Take care.